Okay, so we saw a very simple example of a shell script, but shell is much more powerful than that. It can it can be used to do much more complicated commands and not only echoes to display some text or some variable contents. So inside the shell scripts, you can add many types of controls. If you wanna, for example, to execute something, a command or any other program, depending on the value of a given variable, you can easily do that, adding the if statement followed by a conditional expression between brackets. So if the conditional expression results on true, I mean if the statement is true, then the program is going to execute the list of commands that comes after the then. And if not, you can specify another list of commands, and you end the control, the if statement control, by typing phi to say that you ended this control. So this part is optional. What I mean here is that in an if statement, you need a conditional expression and a series of commands that you want to execute if the statement is true. But if you add the else followed by commands, these commands will be executed if the conditional expression results on a false. Let's take an example to explain better. I'm not going to write in parallel in the terminal, just to make sure I'll explain the different statements, and of course I highly invite you, I encourage you after that to do to stop the video and to do to test this script in your terminal. I mean, we're gonna test it in my terminal, but it's already written. So remember, to start a shell script, you always need to mention the shebang. So here it's a bash. The bash is going to be the interpreter for the script, and I'm starting my script by doing an echo to display a sentence. And remember that we said that echo could be used to kind of interact with the user, especially if you are executing commands that do take a lot of time to finish. For instance, if you are doing some and followed by QC and followed by many other commands, you can use the echo to alert the user, for example, that you are done with the alignment step, and that the system is currently running the quality control checks, for example. So I'm then defining a variable called x. As you can see here, I'm using the backticks. So the x is gonna contain the result of the command. And as you see here, my command does contain a pipe. So basically we have two different commands. The first one is here, and the second one is the wc-l. So remember, the pipe means that the output of the first command is going to be given as an input for the second one. So the first command here is a find, and I am using the wildcard star .fasta. So this basically refers to any file ending by .fasta, and the find is a command that displays all the files that match this pattern, basically. So the result of these two combined commands would be the number of files that do have a .fasta at the end of their names. So I'm creating another variable called y, and I gave it 2 as an initial value. we then want to display the content of the x variable. So we are displaying the content because x is preceded by the $sign, but we want to display it inside a sentence saying that explaining the result, if you want, of the command. We are then adding a control statement. So the idea here is to compare the value of x and y, and to say, so remember that y is 2, and the gt here means greater than. So we are saying if x is greater than y, then echo there are many existing files in this directory. And if it's not the case, if this statement is false, that means that x is smaller than y. We're gonna display there are very few FASTA files in this directory, and here we chose to list the different files. Remember, the back ticks always give the result of a given command. So if you saw here, there's an hash followed by another control statement. So a hash in any scripting language mean that this is a command and the interpreter is not going to interpret what is going on after this. And I added this just to give you another example. So you can, instead of writing this conditional expression, replace it by this one. It's exactly the same. Remember, I told you the GT is greater than, and we are replacing it by the symbol. But the main difference is that if you use the GT, you have to add brackets here, but if you use the greater than, you have to add a double parenthesis. So I invite you to try this script in your terminal or in your webinar. I've already prepared this script for you, so it's my test for, oh, it's my test conditional script. Alright, so let's display the content of my test conditional, and here I basically copied the content of the example I have in the slides. So Control X to exit the nano, and I'm going to type test conditional. I've already changed the permissions, so I have the right to execute. So as you can see here, it's let's try some conditional tests, what we wrote in the very first echo, and then the current working directory contains only one FASTA file. If you look at the content of my directory, you have only one single FASTA, so the result of the find command was that single FASTA file, and followed by the wc-l gave 1 because the number of lines resulting from the find command was just 1. So then we did the test. So is 1 greater than 2? The statement is result is false. So we displayed what was given in the else command, which was there are very few FASTA files in this directory, and we should have the listing following the result. Let's check that, and yes. Here we have the listing following because we followed our echo by we asked our echo to display at the end the result of the ls star.fasta. So this is why we saw the name of the FASTA file, of the unique FASTA file existing in my directory here. Of course, if you are working in the directory in which you created your FASTA file you had in the assignment last time, you're gonna have a result for your find command, otherwise it's gonna be 0. You can replace .faststate by .txt, and you can create simple .txt files to test that. And otherwise you can just replace it by file start to say all the files that do start by file. Remember, we created file 1 and file 2, so I mean you can still play with these wildcards and change different options to see the different results possible. So another strength of the shell scripting is the fact that you can repeat a given treatment different times. Imagine you want to execute the same thing on different files. You can simply use the for loop, and the syntax for the for loop is for variable in a given set of values, and then you have to mention the list of commands that you want to execute for these different variables, and the commands should be contained between a do and a done, and the done indicates the end of the loop. Here is another very basic example. So remember the file 1 and the file 2 we created, and we want to do a treatment here on these two different files. So I'm defining a variable x that can have two different values, either file 1 or file 2. And then we're gonna repeat a treatment on these different x values. So each time we're gonna display the three first lines of the file, and then we're gonna end by saying it's operation completed on that file. It's just a kind of message to the user to understand that, okay, I finished dealing with the first file, and I'm jumping to the second file in the list, and third, fourth, etc. if we do have here more than one file. Let's see the result. Let's see the result of this script. Of course, you can stop the video and take time to write this script, but I'm going to show you here the result. So I'm cleaning my screen to ease displaying the results. So I used the clear command, and my file is named for test script for. Okay, let's do an ls to check. So it's a test for, and I'm going to clear again and type test for. I've already changed the permissions, so I have the right to execute. So as you can see here it's the content of the three first lines of file 1, and then remember that we asked the shell to display a sentence saying operation completed on file, and given the value of x, which is the name of the file that the shell has been dealing with first. And then you have the three first lines of the second file, and then again the shell is displaying the message to say that the operation is completed in the second file. So as you saw, x took two different values, sorry. So in the beginning it was file 1 and then file 2. So in the beginning we had to deal with file 1. We displayed the three first lines of the file 1 because we are using the head command. This is why we displayed the three first lines. And we also displayed a message saying that we completed the operation on file, and the value of x, which is file 1 in the beginning, and then file 2. Again, I invite you to do that via your terminal, either now by stopping the video or taking time to do this later.